Now let us see developing winding diagram with respect to wave connected windings. So DC wave windings, number of slots 30, 4 poles, single layer simplex wave winding. The last example we saw for single layer simplex lap winding. So here M is equal to 1, that is YC is equal to X is equal to 1. Then number of conductors, it's not YC is not actually equal to 1, it is actually X is equal to 1. So there's a small mistake here. I repeat, YC is not 1, you have to calculate YC. As told earlier, there's a different formula. So total number of conductors is 30 Z, and pole pitch is Z by P, that is 7.5, but we take 2 conductors extra and we say that the pole pitch is 8. What exactly is pole pitch? So pole pitch is how many conductors would come under one pole. So we can't take 7.5, right? So we round it up and say that it is around 8 conductors. So how do we do? By taking 2 extra coils, and those 2 extra coils are called as dummy coils, right? And then commutator segment. Number of commutator segments are, there is Z into M by 2, right? That is 30 into 1 by 2, which is again 15. How is M1? Just because it is simplex, right? And then Y average is given as YB plus YF by 2, or is also equal to YC, and this is a mistake in this video. So this is actually for lap, right? For wave winding, the formula for YC is given as Z plus or minus 2X by P, right? So where X is actually 1, so X is actually 1, and there is nothing but X is equal to M actually, right? So then we get this as 8. So now we have to select as 7 or 8. So for progressive it will be 8, and for retrogressive it will be 7, right? But they say that the V average should always be odd. That is, if YB and YF is odd, V average also should be odd, right? So then Y average, if I take 7, only then YB and YF will also be odd. So YB and YF should also be odd always. So this is one of the criteria under wave. So YB and YF, I'm not saying the summation, YB and YF should be odd, thus V average also will be odd. As we know, summation of odd will always give us odd, right? So thus we take Y average as 7, and then we have YB plus YF is also equal to 7. Let us see how do we draw a winding table with respect to this. So YB is positive, YF will be negative. So we start from first conductor. So 1 plus 7 is 8, and then 8 minus 7 is, sorry, 8 plus 7 again, right? 8 plus 7 is again 15. So here in wave we have to add, whereas in your lap winding we used to subtract, right? And then 15 plus 7 would be 22, and 22 is within 30, so no problem. So 22 plus 7 again is 29. 29 plus 7, how much do we get? We get 36. So how much winding? So when you subtract 36 by from 30, that is 36 minus 30, we get 6, right? And again 6 plus 7 we get 13, and then 13 plus 7 we get 20, and then 20 plus 7 we get 27, and 27 plus 7 we get 34, and here it is 4. So what we do is we subtract by total number of conductors, right? That is 27, I repeat, 27 plus 7 we get 34, and we subtract from 30, so we get 4 here. And similarly now 4 plus 7, 11, and then so on. And now we got 2 here. 25 plus 7 we get 32. So here instead of 32 we write 2, because we are subtracting 32 from a total number of conductors, that is 30. And then similarly we go on. Similarly here 30 plus 7. So 30 plus 7 is 37. So 37 is more than a total number of conductors. So we subtract from 30. That is 37 minus 30, we get 7. And then we go on. I hope you understood how we got 5 here. It is 28 plus 7, we get 35. 35 minus 30, we get 5. And we go on and we stop until we get 1, right? So 24 plus 7 is 31. 31 minus 30, we get 1, right? So here is only addition. We subtract, because if the number goes more than total number of conductors, to get number of windings, right? So you can see here for port pitch we have taken 32, but while drawing the while calculating your winding table or drawing the diagram, we'll see what we will consider. So while considering for the winding table, we have considered as 30 itself, right? When we draw the diagram, we'll consider 32 number of conductors, because we have to select 8 conductors under one pole pitch, and we cannot select a fraction, right? And number of commutator segments are 15, so we'll have 15 commutator segments. And as told, we'll have 4 poles. For wave, although we know number of parallel paths are 2, right? For good commutations, we will always prefer having 4 poles. So here also you will see, while drawing the diagram, you will see 4 poles rather than having 2 poles. So 32 by 8 is equal to 8. So here you can see this is for example, blue color is north, black color is south. So you can see there are 4 poles, right? So 4 poles would be coming under these conductors, right? So then their numbers are 1 to 32 as told, that 2 extra coils we have taken. So north south and north south, right? This is your table. So we'll see how do we draw. So 1 goes to 8, right? And then from 8 it goes to 15. From 8 it goes to 15. Then from 15 it goes to 22. So from 15, as it is wave, it follows the path. From 15 it goes to 22, and then from 22 it goes to 29, and from 29 it goes to 6. So from 29 it goes to 6. So here 6 is collecting from 29, right? And then from 6 it goes to 13. So at bottom, from 6 it goes to 13, and from 13 it goes to 20, and then again from 20 it goes to 27, and then from 27 it goes to 4. So that means it has to collect here, 4 has to collect here from 29, right? And again from 4 it goes to 11. From 4 it goes to 11. From 11 it goes to 18, right? Then 18 it goes to 25, and from 25 it goes to 2, right? So here it's going to 32. So 32 or 2 both are same here, right? And from 2 it goes to 9, right? So from 2 here it is going to 9. So here from this 2 or this 2 both are same, right? So similarly the connections are made as per the table. Then from each diamond shape windings, so we extend lines, right? And we draw two lines for commutator segments. And commutator segments, as discussed, there are 15, right? And as told in the last video, so from this winding, right, from this connection, it goes to one complete commutator, right? So this complete is one commutator segments. So like this, how many commutator segments we have, we'll see, right? We have 15. So let us start naming, right? So 10, and then we'll have so at this end, this is small mistake again, this has to be at the end here. So this is at the second 32 or 2, right? So you can see again this is starting from 2. So I'm sorry, this is a small mistake, this has to be at the end. Okay, so this your second 32 or your second conductor is connected at 11th commutator segment, and again here the second conductor is connected to 11th segment. So thus we have 15 commutator segments here, right? So now after doing this, we have to connect your carbon brushes. As told, we'll have 4 carbon brushes. Now how do you divide among 15? So let us say we have 50. When we divide 15 by 4, 15 by 4 we get around 15 by 4 around 3.75. So let us say we have a carbon brush at 11, 1, 2, 3, and then at 15, similarly at 4 and at again 8, right? You can take either a difference of 3 or a difference of 4. Okay, either a difference of 3 or a difference of 4, join those two, so this becomes your A and this becomes your AA, right? So that's how you draw your wave connected simplex simplex wave winding.